8 minutes after 7 o'clock.
Well, do you find yourself wondering how to throw the perfect curveball? Or wonder how, Brett Favre does it, or how Kerry Wood's pitches are so perfect?
I wonder how they go so fast. But our favorite mad scientist and wise guy, Matt Stillman, is here to teach us again about the physics of sports. Good morning, Matt.
Hi, Gay. Hi, Matt. So, I'm not a real athlete, I have to say that up front. But I can play with cool little demos like this and pretend that I am. So, in the last segment, we talked about football, and we saw that the reason we wanted to spiral it was to keep it facing in the same direction all the time so that we could minimize the effect of the air on it. And in the case of baseball, you want the air to actually do things for you. So the demo that I have right in front of my face right now is I have air blowing out of this pipe, and I'm balancing a styrofoam ball on this air. And I'm just going to tilt this over a little bit, and you can see that it starts to spin. You'll also notice that now I'm pushing from one side. I'm not pushing directly below. So you might be wondering what keeps this thing from falling down, because gravity pulls straight down. And what happens is, as the air rushes past the ball, okay, on this side, it kind of sticks to the ball and it gets deflected to your left, okay? Now, Newton's third law says that if the ball pushes the air to the left, the air must be pushing the ball to the right. So what happens is there's a force acting on the ball making it go this way, okay? The way to remember it is, as the ball is rushing into the air, the ball is going to curve or be pushed in the same direction as the front of the ball is spinning. So in this case, the front of the ball goes this way, so there's a force pushing the ball this way, which keeps it from falling down from gravity. If I just turn off the air, this thing falls and hits me on the head. Okay, so I'm going to turn off that air so I can hear what I'm saying. And now I'm going to try to throw a curveball. So remember, what I'm going to do is I'm going to make the ball spin this way, okay? As it comes towards you, the air is going to get tossed that way, and the ball is going to curve to your left. Okay, so it's going to spin like this. I'm going to use these little balls because they're easier for me to chuck. So I'm going to stand back here and throw it at the camera. Let's hope this works. Okay, now I could see it. I don't know if you could, but it did definitely curve like this. You have to take my word for that. And the reason was that it was spinning like this. Okay, so just remember, as it goes into the wind, whichever way the front of the ball is turning as it moves forward, that's the way the ball is going to curve. So you can get it to curve this way or that way or up or down.
I decided to curve that because otherwise it would have gone right at Scott's camera.
Yeah, sort of like that.
Like that, yeah.
Now, I want to thank those folks who did send email questions, and we're going to answer some of those next week.
Okay.
I had a great question about hang time and then some questions about static electricity, which we'll get to eventually. And I want to encourage people again to send email and ask more questions because that's a lot of fun.
Okay, well, if you have any questions for the wise guy, write him, email him here at the station, news@wcia.com. And Matt, we appreciate you being here today. Fun with science.
Have a great day.
We'll see you next week.
I want to invite him to a party.
Yeah, he would be a fun guy at a party, wouldn't he?
Show up with buckets of liquid nitrogen and stuff.
Our weather on the 3s is coming up next.